Alright, hello guys, welcome back. This is a video on how to install an open source program called OpenFast Wind Turbine Simulation. This is for Windows 10 only. I have not tested on Linux, Windows 11, or Mac. So, this is a really interesting piece of software, and it's pretty good at doing a lot of different types of testing. So, for example, this is a 5 megawatt wind turbine. It's about 90 meters tall and about 63 meters in length for one of these blades. And that's kind of the baseline of what we're going to test and use this software to test for. So there's tons of outputs that are provided in an Excel file that we'll use, but I'll get to that later. So we're just going to show you how to install it. I'm just going to show you how to install it and then use the basics of it. And like I said, there's about 2,900 different types of outputs selected from that you can select from the Excel file. For the basic testing, it's default of 12 meters per second wind speed with some turbulence. It's not a constant wind speed, it is a turbulent wind speed. So, with that in mind, this is how you're going to install it. On your drive, anywhere in your hard drive, such as My Documents, you're going to create a folder called OpenFast. And then you're going to click this link, and I'll provide this document. And this is all of the stuff you need to download. There's multiple things we need to download, but for this section, we're going to download all of this code, and it's pretty simple to do. You want to make sure it says RC 3.50. That is the current edition. So you're going to click where it says code right here, and you hit download zip. And then you're going to download it. And then there's another file nested within another place, so where it says reg tests, you're going to click that. And then this folder rtest, you're going to click that. Do the same thing with code, download zip. And then that's going to download everything that you need for the moment to your OpenFast folder. So what you're going to do is right click on each one. I use 7-zip, but Windows automatically has something where you can hit extract all, and it should make its own folder and extract both of them there. The next thing we need to do is download some of these DLL files and this OpenFast x64 executable. This fast farm, that's if we're testing a wind speed farm. This is beyond the scope of this document, so we're just going to be sticking with one wind turbine. Now I call them windmills because windmills are awesome, but it's really a wind turbine. Okay, so back in the document, once you've downloaded these, there's this other link right here where we're going to find these DLLs. You're going to click it. It's going to take you here, and we're going to scroll all the way down to the bottom underneath something called assets. So download discon.dll, all 4 of these discon DLLs, and then the last one is this OpenFast exe. Download those all to the same directory of OpenFast, just right there. Don't put them in the ones you unzipped and decompressed. Okay. Now that you have everything there, we're going to do a basic test. And it should work pretty simply. So what we're going to do is you're going to open up your My Documents and open up OpenFast. Then we need a second window. So you're going to right click this folder icon down here and hit File Explorer and navigate to here. You're going to slide it over here until it locks, and then it will fill in the screen. So you have these 2 file folders open. So now we're going to navigate to OpenFast, rtest, click that one again, glue codes, OpenFast. We're going to test out the 5 megawatt land DLL wind turbine. Okay. So then what you're going to do, and it's going to error out, and that is okay. You're going to take this .fast file right here, and you're going to drag it, and you're going to drop it right onto the exe. And it's going to take about, 30 seconds or so. It's going to go through. For mine it'll work, but yours it's probably going to fail because we have to do one thing. It's going to give an error saying there is not a DLL in the correct folder. So if we go back to OpenFast, just one directory back, you see this baseline? If you go in here, you will see, where is it at? I think it's in servo data. Yes, in servo data, you need to copy this DLL file right here, the discon.dll, and paste it into the servo data. And now it will run correctly. Okay, so now that you've run your first test and it works, what do we do? So go ahead, you need to install another program called Notepad++. And I don't need to show you how to do that, but once you get that installed, if you go to this .summary, you right click and you edit with Notepad++, it's going to tell you a summary of what was done. Requested channels in the output. So channels is a test. This is a calculation it did. So channel 1 is time. Wind velocity in the X, Y, and Z. This is generated by something called inflow wind. Okay. Then LSS, GAG, MYA, I forget what that stands for, but it's kilonewton meters, so some sort of moment. And it was performed by another program that is already in the files. It's called Elastodyne. And all of these are done by Elastodyne. There's actually 59 tests that it did. So the blade 1, so B1 is blade 1. These are different like flexes across them. Some of these aren't going to work like 4, 5, and 6 because that means, notice it stops at 3. This is for a 4-blade turbine, 5-blade, 6-blade, which I don't even think they make, so I'll show you how to edit the correct file in a minute. So let's look at that. 58 and 59, generation power, generation torque. So it tells you what the outputs are, the units, but it doesn't tell us anything useful. So how do we read it? That's an excellent question. But another file I want you to look at. No, let's read it first before we start editing things. Okay. So, back in the Word document, we need to scroll down until we find the section about MATLAB. All the results will be plotted in MATLAB, so make sure you have access to MATLAB. Click this link, we're going to the MATLAB toolbox. We need to download a file called readfastbinary.m. You're going to click it. And you can either copy the raw file or just download the raw file. Yes, if you just click download, it'll put it in the .m format for you to use. And save it. Okay, save it to the working directory of the 5 megawatt land. Oh, not BD, we don't want that one. Sorry, we need to go to DLL wind turbo. There we go. So download it to this working directory. 5 megawatt land DLL wind turbine. That's where you need to download it to. Because this is the one that we are testing. Okay. Once it's downloaded, all you have to do is double click it. It's going to open up MATLAB. And then in the Word document, I supplied the command to run first. You want to run this command first. Notice the output file is 5 megawatt. This is why you need to be in the working directory, and it's the .outb, which is the output in binary format. So, in the command window, you're going to paste that. It's going to run. And notice up here in the right hand corner, it's produced some sort of data. So notice channel name. That's what we're going to click, and there's all our outputs. the wind in X, Y, Z, all these things, and 58 and 59 are the torque, generation, and power. Okay, great. But now how do we read it? That's an excellent question. So now we need to display the plots. So we're going to take this other set of code and we're going to paste it. But notice it says I channel equals 2. The channel equals number, this is meaning to plot channel 2. But if we want to plot channel 5, all we have to do is change it to 5 in these two places, and then copy, and then paste. But what's channel 5? I don't remember what that is. It's some sort of moment, but now it'll produce this. So this is what our graph looks like of some sort of moment. Now let's look at the wind speed. So let's go ahead and paste that code again, but I don't want it to automatically run it. So let's go ahead and copy it from here. Control copy, Control V, and that'll prevent it from running automatically. So I want to go to channel 2. And if it doesn't show up, just zoom in a little bit. Notice it says the wind velocity in X direction is the solid 25 meters per second. Okay, we'll discuss this here in a moment. So just remember this, it's a constant 25. Now I said the default is 12. So yours is going to look different. Yours is going to be all sporadic and everything. That's because the default value is 12 meters per second with turbulence. I have changed mine to a solid 25 meters per second constant. Alright, so let me show you how to change inputs, these channel names, and add things before we deal with the wind speed. Okay, so I'm going to minimize this. Minimize that. What you want to do is in the document there should be a link to this outlist parameters.xlsx file. This is an Excel file. You're going to want to open that up. Okay, so let's go ahead and I'm going to open mine up. OpenFast. Okay. So, you'll notice there's 895 options right here, but notice the tab down here is Elastodyne. What does that mean? Okay, so if we go back to where we were, we have these things called aerodyne15.dat, elastodyne.dat, elastodyne.dat.backup, you don't need to worry about that one, tower.dat, servodyne.dat. These are all input files that we can edit in Notepad++ to calculate different things. For this document, we are sticking with the basics, which is elastodyne.dat. So, right-click, edit with Notepad++. That's going to open this up. You can read the initial conditions and all these fun things if you want, which is awesome. It'll show you some really cool things. What you want to do is scroll down to where it says Output, right here. And then this section right here where it says Outlists. The next line or lines contains a list of output parameters. So you'll see all these things in quotes. That came from this Elastodyne this Excel file for Elastodyne. So, rotating low speed shaft bending moment is this one right here that I put in. High-speed shaft torque, kilonewton meters, that's a moment. Oh yeah, torque, duh. Power and kilowatts. So let's take this one, double-click it, Control-A, Control-Copy, and then minimize, and I forget which ones are invalid, so I'm going to remove the invalid ones. Invalid was anything from 4 to 6. So from 4, I'm going to get rid of these ones. down to 6. I'm just going to put a quotation mark, paste, quotation. I don't think I have that one in here. I might. Nope, I don't see it. Okay. Then Control S for saving. Now you can, if you wanted to, take this description right here and put it in here. Just remember, whoops. You just do the spacing. Sorry, just use the space bar until you get to right about here. Dash. And there you go. And then paste it. So, Control S. That should be, so time is the first one. That should be, and wind speed. Where are all my wind speeds? Am I using the right one? I gotta make sure I'm editing the right file. Yes, I am. Okay. Cool. Alright, so we saved it. And everything should be good. I'm just gonna minimize it, keep it open, minimize this. Okay, now to rerun it, you're going to take the .fst file and you're going to drop it back on the exe. And it's going to do its thing again. Alright. Okay. Then go back to MATLAB and we have to run those codes again to regenerate our data. Okay, notice it says 59. Now it should say less than 59 because I removed quite a few and then added the 1. Okay, so 51. Let's go back. Let's close this one out. Double click it again. And it should be right here was the new one, 15. So channel 15. So I'm going to go back up to here. Copy. Control copy. For the plotting. I don't. Okay. Channel 2. I don't know how to prevent it from stopping. Dang it. Okay, give me just a second here. Control copy. Do not auto run it when I paste it. Okay. Sometimes it does, sometimes it doesn't. And we want a channel 15. Okay, there is the high-speed shaft power. So that's our new input that we added. Okay. So now if you go through the Elastodyne file, you can see different, just make sure that it, gauge 6, okay, yeah, just make sure it's worked for a 3-blade system, and I think the only one was that had that issue was what I was using with the span. So span station 3, so only stay at 3 with anything with the span. If anything above that, I don't know. I was told by the devs of this that it means you're using more than 3 blades for testing, and you don't want that. Okay, so you can go through and see tons of different stuff. Do not worry about beamdyne nodes or Elastodyne nodes. Inflow wind, we'll be dealing with this next. There's only a few things you need to worry about with this one. But the Aerodyne, if it has an Aerodyne file, you can add this, things to it just like we did, but you don't want to use beamdyne. Elastodyne is more dynamic and just simplest at the moment for what we're doing. Okay, so I'm going to go ahead and close this. I'm not going to save. Okay, I'm going to close MATLAB. Now, let's deal with wind. So you notice it was a straight line for our wind, while yours probably looks like this. So let's take a peek at that. If you go to the actual folder, your working directory, right click the .fst file, click edit with Notepad++, you'll notice this section called input files. So it says beamdyne, inflow wind, etc., etc. This is everything that it's using and unused, etc. and stuff. So this folder right here, the 5 megawatt baseline folder, and then there's this NREL offshore baseline 5 megawatt inflow wind 12 meters per second .dat. That is the file that contains all the information about wind perimeters. So let's go find it. So it told us it was in the OpenFast 5 megawatt baseline. It was called the NREL offshore inflow wind 12 meters per second. Right click, edit with Notepad++. Okay. Alright, the most important thing on here is this wind type. This is what switches it from steady to uniform to turbulent, etc. So by default, yours is set to 3. 3 is a binary turbsim file. Full filled file is what FF means. Okay, if you come down here where it says parameters for binary turbsim file, used only with wind type 3, it's pulling this file .ptes file right here. This is a binary file that is generated by another program you have to install called turbsim. That'll be a second video. And so this generates turbulent wind simulations for OpenFast. But now if you just want steady wind, change this to 1, and then right here below where it says parameters for steady wind conditions, used only for wind type 1, change this value that should be 12 to whatever you want. I'm going to put it back to 12. And then Control S to save it, and then rerun everything like we previously did. Drop the .fst file onto the exe, and then let it finish computing, and then rerun the MATLAB codes, and you'll see how yours is changed to a straight line. Now you can try switching it to 2 for uniform, and it looks like the file for it is unused. So I don't know what happens. You could try it with 2, see if it produces any errors or anything, but generally speaking 1 and 3 are just fine. I'm going to switch it back to 3, which means it's going to use that file, the binary file, which you cannot edit the BTS to change you cannot manually change the wind like we just did with steady. You have to regenerate it using turbsim. So that'll be another video. So make sure the .fst that you drop is not the one in baseline. You want to go back to land DLL, wind turbine, .fst, drag and drop. Okay, one thing that I did while that runs, I have this commands to get outputs from OpenFast. This, if I copy and paste, will not auto run. Okay, so it finished, so let's open up the binary. Okay, I'm going to close remind me later. I'm going to close this one. So notice your working directory is where the binary is. That's what you want. So Victor. Okay, channel names. Wind and vertical X. Let's check out 2. It should be I'm going to close that one. Save. Okay. open this one. This test code below, it works, but it doesn't, so be very careful using this at your own risk. Okay, control copy, MATLAB, control Victor. No! Why do you keep doing that? Okay. How about I just paste it? Okay, whatever. It takes like 3 tries, I swear. So I guess what you're going to have to do in here is just change it to 2. And then go ahead and paste it. Okay, now we're back to the turbulent wind, which is what I like. So, that is the bare bone basics with a little bit of advanced stuff of using OpenFast to produce some sort of results. So, with the let's look at one more plot though, just because. If you do steady wind, one thing I suggest is look at your torque generation and your power generation, so channel 1551, with steady wind versus turbulent. It's actually kind of cool. What was it? Did I say 50 and 51? So, control copy. Oh, now it lets me hit enter. I don't get it. Yeah. So the output actually looks a little bit different with steady wind versus turbulent. But you can see it settles right around, like at 20 seconds, there's this dip in power. I don't know what happens at 20 seconds. Well, we settle right around the 5 megawatts. So let's do that again, but look at channel 2. See what happens at 20 seconds with the wind. I guess maybe for the wind just, yeah, but only 11 to 11.2. Yeah, 11.2 meters per second, so not that big of a decrease. So I don't know, something happens at 20 seconds in that causes a dip in power. Anyway, okay, there you go. I hope that helps you guys understand how to install OpenFast, or anyone to install OpenFast, and how to use it. So watch out for the next video. That's when I'm going to use TurbSim to generate turbulence and different wind speeds. You know, like hurricane wind speeds. See what happens there. Which is bad. It's going to ruin the wind turbine. But hey, okay. All right. Once again, thank you for watching, and have a great day.